Okay, I think I'm live at this point, hopefully. So hey, and welcome to the stream. So today we'll be continuing with our Sudoku Solver. And in particular, what I managed to figure out, I think I already talked about this in the last session, is that for the very complicated Sudoku puzzles that we run into, we kind of need to ramp up the difficulty of the solvers that we are using. And in particular, to one method that was missing is fins, as in we already have the fish rows, which I can go through and re-explain, but basically there's an extension of this that's called the fin, and then the corresponding fish, which kind of allows you to eliminate not exactly as much as the fish rule would, but it allows you to apply it to situations where you kind of almost have a fish. So it's a very powerful rule set, and again, you can kind of ramp it up, to the different sizes. So it's pretty generic, but it will be actually very tricky to implement. I'm not sure how to do it yet, so this stream will be interesting for sure. So I guess let me just run through what I'm talking about. So the basic fish rules, and again, this is a thing that kind of scales with size, so you can kind of have a 2x2, 3x3, and so on. So, but the logic is the same. So the 2x2 fish is called X-wing. So what happens is, imagine that you have a situation where, this is a great example. So these two rows, the row 2 and the row, 1, 2, 3, 4, 5, and row 5. So if we look at the number 5, so the number 5 can only be in two positions in these two rows. Well, when that happens, that means that if I put a 5 here, well, then there can be no 5 in these two positions, and the 5 has to be here, right? And vice versa, if I put a 5 here, well, then that forces the 5 here. And the important logic or pruning you can do based on this is, well, now this 5 is impossible. Why? Well, either the 5 is here or it's here, and no matter what, there will be a 5 in this column, no matter what you do. And this logic kind of expands to, more instances, as I said. So this is a 3x3 example. So we have this row, and this row. And overall, they have the number 2 in 3 different column positions, right? And it really doesn't matter how exactly the columns are distributed. It's just important that if I have 3 rows, I have 3 columns if I look at the possible positions of a specific number. So in this case, the number 2, if I start doing the logic, okay, if I put the number 2 here, well, then obviously the number 2 will not be here, which means it will be here, which means it will be here. And you kind of have these forcing chains where, oh, if I pick a position here, then it cannot be here in that position, and so on. What it always boils down to is each of these columns can only have the 2 in the positions that are already occupied by these rows, right? So these two 2s that are in a different rows than the ones that we are considering for the fish, well, those are impossible because there will always be a 2 here or here. There will always be a 2 here or here. There's no other option, because otherwise you just break the fish. So that's kind of what it boils down to. And what the fins do is, it's kind of, you almost have a fish. So let's look at this example, right? So if this blue 9 didn't exist, well, then obviously we could just clear this red 9 because we have a fish, right? We have 4 positions. Those positions are in 2 rows and 2 columns, so it's a fish. so the 9 can be safely cleared. But we have this blue 9 here. That kind of breaks the fish, because now if I just go and count the number of possible columns, well, it's free, right? Like this row has the number 9 in 3 columns. So this would mean I would be looking for a 3 by 3 fish, not 2 by 2. But the tricky part here is this is kind of an extension of this 9 because it shares a block. So this is what we call a fin. And you kind of, if you look at this row, like the 9 is either here, which means it's not part of the fish, or it's here and then it is a part of the fish, or it's here and it is part of the fish. So for this row, you could kind of say, okay, like the 9 is either part of the fish or not. And if you think about it, in either case, this 9 is impossible. Why? Well, if it's part of the fish, then it's just from the fish row, right? Like this 9 cannot exist because it shares the column with the fish. And if it's not part of the fish, then it's here, but this 9 also forbids this 9 because it shares the block with it, right? So it's a little bit more complicated logic, but it kind of follows the same idea. Where this becomes tricky is how the heck do I actually implement this? Well, that's a very good question. I'm honestly not sure right now. Basically, like what we do right now, we just go and try to find like sets of so in our code right now, what we do, basically have a function that takes as an input the size of the fish and the number we are interested in, right? So for this example, it would be like we are looking for number 9 and the size is 2. Well, if that's the case, and then we just count like, is it actually a fish? As in, if I take, these 2 rows, do they form a fish? As in, does the union of the possible positions of the number 9 end up being size of 2? Because that's when we get a fish. So now we cannot just simply count the union of the positions, because the union of the positions for the row for like this kind of setup would be 3, because this 9 would be the third one. But what we kind of want to do is say, we can have like multiples of the number in the same block. So it's like an additional interaction, right? Like so far we only talked about rows and columns, but this kind of introduces the extra layer of interaction where suddenly we want to also look at the block. And more importantly, so the extra layer of trickiness here is I don't actually want to do like the full fish propagation afterwards. Like if I find this kind of setup, right? Imagine that there was, so there are extra 9s here, for example, right? So if this was actually a fish, this 9 here would actually be eliminated. But I cannot do that with this setup, because it could be a fish, but doesn't necessarily have to be. The only 9 that I actually can clear is this one, because this one is kind of forced by both the fin and the fish itself. So it's not just the search algorithm that is different, it's also the pruning itself that we can apply. And one thing I was trying to figure out, and I also asked this on Reddit, and I didn't really get a satisfactory answer, is whether we can have multiple fins. I mean, you kind of obviously can have multiple 9s within the same block. Let me actually jump to let's see. Let's just jump to some random Sudoku. Right, so okay, so if we have, okay, let's do this. Okay, if you would have this kind of setup, right? Well, it doesn't matter how many extra 9s are here, right? Like, so that's the fin, then this would be the fish, and okay, let's say like it doesn't matter how many of these extra 9s are here, because they're still on the same row, so that's totally fine. We can always eliminate this 9 no matter what. But it's not actually that easy, right? Like, I cannot just count the number of blocks. So, okay, imagine this situation. So if I swap this around, right? Well, if I was just counting, this would break, because I would basically count this. Well, it's still a fish because this is here. Okay, let's just get rid of this. Okay, like this, right? This is still a pattern that you can do something with, but it's not a fish. I mean, technically it's called a fish, but like it's actually, where the hell was it? Let me just quickly run to this. No, Siamese fish. Oh, the turbot fish. So this is, they call it a fish, but it's basically a chain, and we haven't done chains at all. This is kind of, chains is a super powerful technique. You basically can solve any Sudoku puzzle with it, because it's kind of like reasoning. You just go, oh, if I put this number here, what does that mean for the puzzle? And then you kind of follow the chain of doing that one action, and you propagate it forward. And eventually you can run into a contradiction. And if you run into a contradiction, then you know, oh, obviously that means I cannot put the number there, because I just generated a contradiction by doing that. So it is kind of like guessing in a sense. Like, it's still like you are doing logical reasoning, you're not actually guessing, you're trying to find the contradiction. But it is a little bit of a guessing, because you kind of guess and then see if that works. It's a bit of weird technique. Anyway, like, the turbot fish is basically a chain, and yeah, and with that you can do these kind of patterns that are not exactly like an X-wing, but very similar. This one is actually called a skyscraper, and there's like a empty rectangle and whatnot. So there are weird techniques that I don't think I will implement. Maybe we will see. I think just having the fishes and the fins should be fine. Okay, not the code. I wanted to, what was I doing? Yes, this thing. So how do I check this? So this one would actually end up with, if I would just union the possible positions, this ends up being 4. So that's obviously bad. So I'm really only looking for situations where only looking for situations where I have +1, not 4. Even though I think like this would actually work, but I'm really not sure how to implement that. So okay, so let's say we just do the +1. So in that case, what I want to do, if I count the union, the union of the possible positions, right? And I end up with a number that's 1 higher than what I was looking for. Can I find which row that is? I mean, this will be quite tricky. Like on the 2x2 it's easy, but I'm really trying to think about how do we do this in general, right? Like I want this solver to be capable of, you know, working with any type of Sudoku. And also, of course, I don't want to just implement Fint X-Wings. I want this to work for like all the sizes of the fishes. This is very interesting. So how would I figure out which row is the one contributing the +1? It doesn't necessarily have to be one row. Yeah, because I can have this kind of situation. Which would that's not what I'm looking for. So I want to find a case. I mean, I can obviously do it just okay. So once I have the union, what I could do is just go through the elements in the union, and if I have a case where one of the elements of the union is only contained within one of the rows, I basically know I have a fin. Is that the only way to do it? Maybe it is. Like, it sounds a bit suboptimal, but I can't really think about any other way to get it. Because again, like, I really need to get to the point where this is like the only square that's extra. Okay, so let's see. So let's think about it. Let me just increase the sure. Okay, so we do the normal fish search, but instead of basically comparing that the size of the union of the positions is the same as the number of the rows or blocks, because we do search, like, first we search for rows and then we search for blocks and then we search for fishes. So instead of this kind of thing, and I guess it would actually be nice if this was part of the fish search, but I kind of want to have all the solving methods kind of separated in a way. Okay. But yes, basically what we are looking for is size of the union is num rows blocks plus 1, but that's not enough. And exists position no, that's not correct. Yes, actually that, yeah. So exists a column in the union, and okay, let's just write it from the one direction so I'm not confusing myself. So okay, so if you are just searching for the rows, so the size of the union is number of rows plus 1, and then I need to find the column where the number of rows okay, when the number of rows, oops, I just realized I'm covering this up, sorry about that, where the number of rows is 1 and no, that's enough. Okay. I'm not sure if, okay, so if we find this piece, yeah, we don't have to check anything more, because basically that says, so if you would okay, so if you find a position where only one of the rows has something in that position, then obviously removing it makes the size of the union number of rows, and it's a fish at that point. So this is all we need to do. But now the tricky part. So this is still not enough, because within this row there needs to be a position that shares a block with the column. Okay, so basically what I'm saying is, let me just put this to the side for a bit. Basically what I'm saying is, I found this piece, right? Well, if this 9 wasn't here, if like, and indeed, let me just move it around, right? So if it was actually like this, so this would still trigger, right? and I would find that this is, this is the extra piece. But then I cannot eliminate this 9, obviously, because, well, it doesn't intersect with the fish at all. So it needs to be true that the fish has something in this block. Otherwise, nothing happens. Right. Okay, I think this sounds pretty reasonable to implement. It will be pretty slow, but to be fair, we should only trigger this like in extreme situations. Like this is the last resort kind of solver approach, where we just tried everything, including like the biggest fishes, and nothing happened. So we just go to this one, which is like the craziest solving technique we have. And to be fair, I have no idea if it will be still enough. We could still be unsuccessful in solving some of the puzzles. But the great thing right now is we do have a massive database of 9 million Sudokus, so we can test it easily. Yeah, I think I'm happy implementing this one. Yeah. Okay. Let's try to do it then. So where do we implement our swordfish? It was in block checker, wasn't it? Oh yeah, and I realized actually that I'm using the wrong naming a little bit. Actually, I'm just looking at my camera and I'm realizing that I didn't set up my lights properly. Is that slightly better? Yeah, maybe. We'll see. Okay, anyway. So, again, what was I talking about? Right. I realized that I'm naming things wrong. So, the thing is, I use like swordfish for like the generic term. The generic term is just fish. Swordfish is specifically a fish of size 3. So actually, I want to go and fix this. So this will be recursive fish find. Okay. Okay. Let's see if I broke anything. It's weird that this says it's never used, but it actually is, so a little bit confusing. Anyway, so this, yes, this should be just called solve fish, not swordfish. Right, and then also in our stats export thingy, I think that one is right now in main. I should just move it out. But basically, this should be fish, and actually, I guess I should just use the proper names for the fishes. Which was somewhere here. Yeah, they don't really describe the fishes, the bigger fishes here. But I'm pretty sure it was it here? Is it Kraken? No, that's a different thing. I've definitely seen one of these websites having like extra names for the fishes. Ah, okay. This thing. So let's just have a simple array of this. Right. Okay, let's just make it no pointer as well. And I guess actually let's just make it properly indexed. So this is 0, 1, and then 2 is equals x-wing and so on. Right. And then basically what we can do is here, I guess, yeah, at most 7. Actually, I just print it if we did anything, because there isn't really a reason to print it out if we, yeah. Okay, so basically that's pretty simple. I just move this in here and don't print anything if nothing happened. So I want the fish name, so fish names at I, and we did it 3 times, right? Right. I guess we could do the same thing for the groups. We can just use the group names, like, you know, a pair, a triple, and so on. But I guess that's okay. Okay, let's see. Let's see how this looks. Yeah, but I need to turn off the static checking because this is really returning nonsense. Syntax error. Wait, what? Syntax error? Curious. I mean, it's still built. Which is even weirder. Like, it doesn't really... doesn't really work together, like either there was syntax error or not. Yeah, I don't know what this is complaining about actually. Yeah, some of these actually are valid, like, yes, we shouldn't have this. Well, no, this is this we actually want to have implicitly. Yeah. Well, yeah. I think the static checking is not really helping me much, but anyway, let's see. Ah, and I guess we should also not print a fish if there were no fish. But that's trickier. I mean, okay, I can still do it pretty easily. It's a little bit awkward, but there really isn't a better way to do this, I think. Header cross false. Right, so the first time we basically come over this, we actually want to print a fish, we'll print the header as well. Okay, let's see. Oops, what did, oh, how did it end up there? That's weird. Let's see. Yeah, okay, now we don't print the fish. Yeah, we don't want an end line here. Yes, okay, that works. Let's ramp it up a little bit. There were definitely some harder puzzles in the database, so I just want to go over those and see how it looks like if it actually prints out any of the future rules. And yeah, like since this is actually taking a while, like I might look into the performance today. We will see, or maybe tomorrow. Because again, you know, I'm streaming some days and I guess Saturdays and Sundays. What am I saying? Okay, another formatting problem. So I managed to delete the end line. But yes, like this is how I want it to look like, basically. Let's just rerun that and suffer through the slowness again. Okay, yeah. Yeah, I'm pretty happy with this output like this. This looks pretty good. So, I'm... So let's go to the swordfish routine, or I guess fish routine now. So recursive fish find, right? So we basically want to have things like this. And basically this part, position size equals set size, will be different. Where's this actually getting called from? Okay. So this finds all the potential sets. And here I'm actually doing the... Yeah, here I'm actually doing the pruning. So what do I want to do where? So the pruning... I guess this should be the part where I decide if this is actually like a proper fin, as in it shares the block and there's something to remove. I guess that should be here. But tricky. Well, in the recursive fish find, I think for sure I want to figure out if there's the +1, right? That's one thing. But I think I also want to figure out if it's only a single row that has the fin. Because otherwise it's not a fin. Yeah. And then when I come here, yeah, here I will need to figure out the block interaction situation. Okay. And technically there can be multiple blocks because like I can think of a situation where we have a diagonal Sudoku, right? And in that case, if you have the extra diagonals, those are extra blocks. And it could feasibly happen maybe not. I'm trying to think if there would be a situation where I mean, there can definitely be like a complicated Sudoku that has an extra block and would trigger on that. So I guess I should make it generic, as in look through all the blocks that are not rows and columns, because rows and columns are the blocks that trigger this. But yeah, we should just look through all the blocks. Yes. Very tricky. Very tricky. Okay, let's see. I will first try to do the recursive fish find thingy. So this will be very similar to this. So we do the same thing. Grab X number of blocks. We look at the positions of number. If the size of the union of the positions is X plus 1, then we might have a finned fish. We still need to make sure that the position that's actually X plus 1, we check if there is a fin, as in a position only in one of the blocks. Yes. So grab X number of blocks, we look at the positions of a number. If the size of the union of the positions is X plus 1, we check if there is a fin, as in a position that is only in one of the blocks. Because let me actually write this down. Because if we then remove the singular position, we have a fish of size X. Yeah. Okay. Oh, actually, how do you spell fin? I'm just realizing I don't know. Oops. Yeah, just fin with one N. Okay. Or I guess just let's call it finned fish. Okay, so fin fish find. So these things remain the same, except we want the positions to be +1. Right, so if we have +1, we want to go over the positions. So for actually it should be unsigned, not CEST. So we go over the positions. Yes, like this. And we need to count the number of rows that have this. Right, so actually it should be unsigned. Start at 0. We go over the set. So lms v what the heck? How do I do this? No, I guess I need an extra. Yeah, basically need a method that tells me whether the given block has a number at the given position, right? So I don't need a new method. Let's just do this for now. So somewhere here, I need a new method. Yeah. That's the number at a given position, right? So the number to look for and position to check. Right, so then this would just be a bool has number at position right? And then I just need to implement it. Right. What the heck? Why did it? Because I can spell, that's why. Oh, now it doesn't want to generate the function. Damn it. Okay, almost. Right. So what I want is that position yeah, is possible is the method that I'm looking for. Right. So we just return whether the position has the number as a possibility. Perfect. Then I guess going back to the recursive faintfish find. So here what I want is if has number at position, the position is P, and no, sorry, the number is the number is number. The position is P, and if this is true, I want to do count plus plus. Right. So once I have run through these, if count is 1, I kind of would like to know which one of the rows it actually is and which position it is, right? Because that would be useful for the like upstream function that's actually going to check if like what can we actually remove. I mean, I guess literally what I want is the XY coordinates of the fin, because from that I can kind of figure out things by myself. So what's the XY coordinate of the fin? Okay, V is the block we are talking about. It gets a little bit tricky because we kind of use this function for both rows and columns, so the XY gets like swapped basically for those. I mean, I can just let the like keep this as it is and just have the upstream function deal with it, which I mean it's possible. I'm not super fond of that idea because I prefer to make like my low-level functions pretty, like I like to hide the complexity as low as possible basically. So it's kind of whenever you use the function, you don't really have to like redo things or rethink things again. Because if I don't do that, like the upstream function, we just need to do this again. Like there's no way around that. But how would I do that? I mean, I guess yeah, I think I will have to do it because otherwise I would have to change my recursive functions. I mean, because in essence what I want is to have a vector which is the blocks, but then some extra information here. And the problem is this actually gets passed into the recursive functions. Yeah, I might be able to like simplify this eventually, but not right now, I don't think. Yeah. Okay, anyway, so if we have the count 1, I guess actually don't need it. So wait, this would be actually true. So we go over all the positions, and if we find a position that's only in one of the rows, actually this should be done here. Yes, okay, so we go over all the positions, we count the number of rows or columns, doesn't matter here, affected, and if there's only one, we know that this is a fin and we just return true. Otherwise we return false. Is that it? I guess that's it. Okay. So then I guess I need to go to this function, right? So I basically need to solve finned fish here. Which will be exactly the same as this one. What heavy is it? What the heck? Wait. Oh no, that's in. Oh, that's in Sudoku? Okay. Why did I think it was in the book? That's weird. Oh, here it is. Okay. Now we still have the swordfish naming. So fish for solve finned fish. Right. Okay. And this is here, fine, cool. So we do this thing, finned fish, fine, right? Yeah. I guess I need to export this in the header. Yep. Okay. Okay, so this is the part where it gets very tricky. So each of the results is a potential finned fish. So for the potential finned fish, yes, I need to find again which is the singular element. For that singular element, okay, let me write this. It's basically what I wrote here before. So we find the singular element, and with this row or column, there needs to be a position that shares a block with the singular element. Okay. Complicated stuff. I think I need a refresh on my coffee. I will be back in 5 minutes. Okay, and I'm back. I need to make some fresh coffee. I just ran out of my coffee. Anyway. Okay. So let's just write it down here again. So each of the results is a potential finned fish. So we need to find the fin and check if it is an actual fin or fake one. If it is an actual fin, try to prune the we try to prune the potential positions shared between the fish and the fin. Okay, right, something like that. Ooh. Okay, the affected rows, remove number. Okay, so first of all, I basically need to do the thing I was doing in the recursive file, which is kind of like this. I guess I actually need to reconstruct the positions as well. So something like that, right? I guess that could be like a find fin helper function where I give it the list of the rows, and I guess this should be a function on Sudoku because it will need access to the puzzle. Definitely can be const. And I guess I need two of them because maybe not. Damn it, this is hard. Okay, let's just make it like this and then I will try to generalize. So this function will really just give me the actual coordinates of the fin, if it is a fin. But what do I do if it isn't a fin? This will actually not help. Oh geez, this is way too complicated. So if I'm looking through so this is doing columns. So when I'm doing columns, I need to find. So what I need to know is the column with the fin, the position of the. I actually don't care about the position of the fin. I care about the position of the fin base, I guess I call it, like the element of the fish that shares the block with the fin, because this will be the row that I will be pruning from. And I guess I will be pruning irrespective of where exactly the fin lies. It's just that it needs to be there. It needs to be an actual fin. And okay, so only prune when the position of the fin base shares a block with position of the fin, right? So what tag do I need as an input? I need like all the blocks that are not rows or columns. That's one thing. I need I guess to make it generic, like basically what I need is the get call blocks, right? I mean, I don't really care if I'm looking through columns or rows. It's just that I need to, but I do because god damn it, this is hard. I need to be looking at the other direction when I'm pruning. So I, like, unless I have a thing that just gives me the orthogonal thing, I will need to understand if I'm looking through columns or rows. Like, there's no way around that. So this will not, I cannot do this in a generic way. I will have slightly different code between these two loops, but that's okay. So I think what I need is to have a function that where I give it two coordinates, and it basically tells me if those two coordinates share a block that's not a row or a column. Because that's the basic check for a fin. Yes. Okay. That should be somewhere here. I mean, this is basically the is seen by logic that I also had on my to-do for today or tomorrow. I can just call it How do we do this? I mean, to make it kind of useful, if I just return the number. So if I just return the number of times it sees the square. So this is basically like the number of blocks that they belong to like together, right? So we already know, like for this particular thing, we already know they share a row or a column. So we know that it has to be one at least, right? Now the tricky part is what you want to figure out if there is an extra block they are involved in. Because if there is, then it is a fail. Okay. Yeah, I think that will be... in that case, I can just score it. Number of shared blocks, I guess. That kind of sounds reasonable, right? Like it's the number of blocks that these two positions share. Okay. This will be definitely closed. So I want to go. So I already have a list of blocks for a position. That was, what was the name of that thing? Block mapping, right? So basically I want to intersect these two vectors. Right. Okay, I give it two vectors. Yeah, I will just make a generic function for this. Count intersections, so vector of t. I guess we want references to this, so we don't copy them. Then I just do if right. If they match, then we have intersection. What are you complaining about? Yes, syntax. Okay. Number of shared blocks. So this will be return count intersections That's first, out at second, log mapping r dot first, r dot second. Okay. Okay. I guess that's all fine. Well, if I have that, then in no, solve, yes, okay. So I want to do the number of shared blocks is bigger than 1 for the fin and the fin base. Right. Well, actually, that's how we find the fin base, right? Okay. So let's do it. So we have the result. Now we need to do the logic from the search, which figures out the potential fin. Oh, that's a different file. Oh yes, this one. Right. So okay, our set is the result. Yes, the positions was then empty set. Okay. So set is result. Actually, that's not the case. This is the size. Right. Oh, not result V, right? Oh yeah, okay, now it's okay. Right. So we go over the column blocks. We figure out all the positions of the number, right? Then actually we can skip this part because we already know that's the case. Okay. But we still need to know the positions. Oh, this is annoying. Okay, let's see. We go over the potential positions for the number and we count. Yeah. His numbered position. Right. This should be. What the heck are we looping here over the columns, right? Oops. Sorry. Yeah, here we are looping over the it's different indexes here. Right. We get the block. We check if it has the number, the position we okay. So here we know this is a true or a fake fin at this point. Yes, yes. So here at this point we know that this is a true or a fake fin. So now we need to do the magic. So now we want to do this thing. So okay, what do we know? We know the row. The row is P. We don't exactly know the column though. Okay. Just to make sure that we don't screw up somehow. So col will be our column index. Wait a second, is this? Yes, okay, so this is zero indexed. Okay, good. So number of shared blocks between. Oh no, this will be another loop. Right. Because now I need to go over. Yeah, okay, so I'm checking only in this column at this point. Yeah, this is not live coding, this is live brain melting. Okay. Yeah, so here I want to go over all the positions of the number within this column that are not at the position P. Yes. Okay, so cat call blocks call number positions number. Okay. If j is the same as p, then we just continue. Is that correct? Yes. And then I just do if number of shared blocks between make pair of so wait, the fin will be position P, so that's the row, and the column is call, and this will be position J and also in the same column. So if this is bigger than 1, so if they share more than a column, then I will have another loop. Okay. Very tricky. So if they share the block, okay, let's go to the Sudoku thing, and let's just undo this. Clonal delete. Right. So let's move to the original setup. So I basically figured that at this point I know that I have these two things there. Well, right now I'm looking at rows, but it's again, it's symmetric, so it will work. So I was looking at this row, right? I figured out that it's actually these two things that are the fin base and the fin. Now what I want to do is look at this column, look where it intersects with this block that's actually shared between these two things. So I guess I actually want to have a function that doesn't return the number. I actually want this function to return the shared block. Because basically I can remove the 9 from these two positions, and only these two positions, like there's no other position that gets affected. Okay. Actually, I can do it without that. So what I can do is I go over the row, which is the one that belongs to the swordfish, which would be J. Okay, so get row blocks J. So I go over the row and I try to find yes, I try to find elements that share a block with the fin. Ah, yes, actually that's the way to do it. Okay, so for so I iterate over the row and I check if number of shared blocks between the fin and between the is actually bigger equal than 1. And I guess k doesn't equal, no, wait, that's wrong. I'm iterating over the rows, so this should be jk, yes. So if k doesn't equal 4, and yes, okay. So if I run into this kind of situation, then I know I can remove the possibilities from this square. So from the jk square. So that would be, what the heck would that be? Data, right? Data jk minus equals number. Okay, super complicated, but I think this is correct. Okay, let's see. Well, let's go through it slowly. So we get the results, right? The results is a list. Well, it's basically sets of columns that form a potential finned fish. So then we look at each of those potential finned fishes. We look at the positions of the number in the finned fish. We already know that this is, you know, the size of that is 1 plus, like 1 higher than the fish, because that's how we search for them. So if that's the case, yeah, so we create the positions then for each of the positions we count the number of columns that actually have that, and we iterate over over the columns that are in the result. Yes, that's correct. So if the column has the number at the position, we just increase the count. And remember the column, because that's important if only one of them has the number at that position. So if only one of them has the number at the position, we know that that's a potential fail. So then what we need to do is figure out, so this is the one column that we care about. We get the positions of the number from that column. Then with those positions, we go over those, and if the number of shared blocks between the okay. I'm not sure about this part, if this is correct. So I go over the, okay, I needed to see it graphically. I go over these positions, so these are the positions of the number. I skip over B, which is B is what? Also, okay, so at this point, right, so I found basically this column here, because that's the column where this row has only one element. Okay. And I have I have it inverse, so this is a column, but that's fine. So I basically know this. Then I look here, I look at basically these two things, which is this loop. Yeah, I skip over this, yes. If the number of shared blocks between, yes, that's correct. P and J, yes. So I found this case, so we have written this if, so we know that these two do share the thing. I go over this thing, so is that correct? JK, so J, yes, because J is the position of this thing, and K I just go down. Let me just split this so it's easier to read. So if J equals the K equals call, then just skip. Right. And if you find the thing that shares a block with this and this, no, sorry, if within this column we find any position that shares a block with this, because we know this already is part of the fish. So if you find any position, which is this one specifically, that shares a block with this position, then we can remove the number. Yes, okay. Whew. Wow. Like, the cyclomatic complexity of this code is insane. What am I doing? It's like 1 for cycle, 2, we are 2 deep. There's an if. We are 3 deep, 4 deep. Like four cycles deep plus bunch of ifs in the way. Wow. I really need to think about like how to refactor this code, because this is insanity. Like, the problem is I don't even know how to test this. Like, this is ridiculous. And now we just need to copy paste this and not make any mistakes. Man. Craziness. Okay, so this is just all inverses. So get row blocks. Get row blocks as number of position. Get row blocks. Number of shared blocks. Damn it, now it actually does look... No, it's not symmetric because here it breaks, right? So this is fine, this is fine. But the number of shared blocks inverses. So now it's... This will be row P. This will be row J. And the same idea here, so this will be row, number of shared blocks, row D with row, no, KJ, yes, KJ. And chain, I guess. And the row that needs to go here. Yeah, okay. Okay, does this even compile? I will need to figure out some sort of test for this. But yeah, this is quite hard. Okay. Well, first we need to adjust our stats. Oh, and we have not another instance of swordfish, so let's just this one called faint fish. This one is to be renamed to just fish. And I guess the same happens here. Faint fish, yep. And this just goes here. Flint fish, right? Okay. And kind of the idea I had is first we want to do the fish size 2 and 3, then we want to do flint fish 2 and 3, then we want to do all the other sizes of fish, and then we want to do all the other sizes of flint fish. So I guess let's do that. So solve flint fish for size 2. Okay, then so fin fish for size 3, and then we have fish size 4, 5, 6. I just get rid of these two. That will not really happen. Actually, do we have a name for fish of size 7? 2, 3, 4, 5, 6, 7. Oh yeah, we do. Okay, so let's just do it up to 7 then. That's fine. Fish 6, 7, and then we'll do the fin. So we 4, 5, 6, 7. Okay. So fin fish 4. 5, 6, and 7. Ooh. Okay. Well, I guess now the moment of truth. Okay. Okay. Let's see if we broke something fundamentally. I hope we didn't. Oh wow. Well, okay, this is very interesting. I was not expecting this. Oh crap, I actually don't remember. let's just comment this out because I don't have the numbers for the previous run. So I just want to see what's the difference. Fish, yes. Okay. So let me just save this. There's our notepad here. And let's see what it did without our fint rules. Actually, I just realized I screwed up because I didn't store the number of solves. But it was something like 9, 8, something. So this is 9805. Okay, let's go back and forth. So wait, so this was like this, right? And let's re-enable this. And this. And let's see. I mean, the good news is it's not breaking our puzzles, so we are not generating any incorrect puzzles. That's what I guess I wanted to say. Yeah, okay, so it's like 50 extra puzzles we are able to solve. That's interesting. And well, actually the stats are very interesting looking at them. This is super interesting stuff. So wait, so there was like 700 million before. Wow, there's like way less intersections happening with the fish rules, with the fint fish rules. That's curious, like why would that happen? And I'm also kind of like, it's very interesting that the fish rules actually trigger way more once I added the fint fishes. I guess that could make sense, like from, if I look at like the fint fish from like one direction, I kind of can create a fish in the other direction because I removed like one of the possibilities. Very interesting. But I guess we are able to solve like 50 more puzzles. But I'm still not trusting myself that I actually managed to write this correctly. Okay, let's see what's the time actually. Okay. I think I will take a short break now, 5-minute break. And I think once I come back, there are two things I would like to do. So one of them is actually writing some tests for these fish rules, because these are really way too complicated to like try to guess them basically from nothing. And I really need to do at least some rudimentary tests to see if basically anything makes sense. And I guess looking at the performance, yeah, I mean, we are able to solve. Originally I had some stats available for like timings, but I removed that from the code. And I guess I should make also the stats separate class. Yeah, okay, I will just spend the time to clean up the things for now, because yeah, there is the main is getting big again. And cool. Well, see you in 5 minutes then. I will just go grab something to drink or snack on in the meantime. Okay, and then I'm back. So, first of all, let's just export the stats object into a separate file. Actually, can I make it from here? Oops. Effector move. Existing or new, right? I want to have solve stats.h. Wait. I want this, I want this, I want this. Yep. Solve stats.h, move. Create new file. Do you want to move class? Yes. Okay. This is one of the very neat features of CLion, like these nifty refactoring tools, but substats, yes. But let's see if it actually did the correct thing. And it kind of did. It put the struct into the CPP file, which is not exactly what I wanted. But I guess I can fix that. Vector unloaded map. What else? Is that it? Yeah, that should be actually it. Square Sudoku. Wait, no, what? Okay, it should be like this, right? And this got removed. Okay, let's see if this builds still. No, it doesn't. So I guess it's missing. Oh yeah, I'm missing the forward declarations. Okay, so the operator is okay, but the output stream operator is not. That one needs to be here. Right. Let's see. Does it work now? And now my CMake is screwed up, of course, because this needs another thing. So this needs solve stats, right? Okay. Reload. Okay. Oh, hey, arrays. Sorry for taking forever to notice your message. Ah, okay, it built, okay. So wait, does it still work correctly? Let's double check. Okay. Yeah, but we need to work on the performance. This is taking way too long. Like the 10,000 puzzles should be quite fast, not as slow like this. Wait, wasn't this number different before? I'm getting very suspicious. Okay, let's just rerun it. If the number was different, that there's something broken in our solver, for sure. I thought it was something beginning with 7, but maybe I'm just misremembering. Come on, run. No, it's the same. Okay, sure. Right. So let's try to write some tests. Okay, let's actually try to draw some tests first. Okay, let's get rid of all of this crap. Okay. I really need to make myself my own UI because I'm just reusing this UI and it's not perfect. Okay, so we can kind of layer things on top of each other because the fish rules only concern themselves with one number at a time, right? So what we can do is kind of create, so this would be an X-wing, right? And then basically removing this one. Then for, I guess we can add more of these, right? Okay, so this should trigger an X-wing for these 2 rows. And I guess there could be like more ones around, that's fine. But this should find this X-wing over rows. Then let's try to do an X-wing over columns, so that would be something like this. And then we can add extra stuff to the rows. So let's say here, and we can have like extra 2s here, that doesn't really matter. So this should not be touched, like this should only remove basically this stuff, and let's like put something here. Okay. So I guess I created another X-wing here. So let's break it. Okay. So this would be 2 X-wings. Okay, let's try to replicate it in the test. So that would be the Sudoku test, right? So what I want to add is a test case. Fish and yeah, okay. So I want to start with an empty Sudoku. So that's a slightly tricky. So basically what I need to do is yes, I can create a friend function that will do that for me. So wait, clear Sudoku. s dot data dot I j dot set test changed. What kind of methods do we have on the square? I don't remember. Debug string. I guess I could minus it with itself. That would work. Oh, reset to empty. Okay. And that's actually a public function. Okay. So I actually don't need the friend function. I'll do it straight up. Yeah, so it's just as ij dot reset to empty, right? Like this. So like that. Now I want to basically hand inject the fishes into the Sudoku, right? So now we need to be super careful. So okay, let's just think about it. So let's do a simple one. So this would be just rows, number 1, and let's just put a thing here and here and here. Okay, so let's replicate that. Okay, I will just put it to the side. So it's replicated in the code. So that would be row 2, column 5 plus number 1, then row 1, 2, 3, 4 at 5 again is the one. Yeah, I should just make screenshots and attach them to the test so I know what the heck the test is doing. Let's try to do that. Okay, edit prop. Where's prop? Okay. Now save as. Okay, so let's save it as test case test fish case 1. Okay. So on the same row, wait, that wasn't okay. So this is correct, but then before that I actually have a thing that was from 2, then at row 5 this, at row 6 I have, oops, so 6 I have something in column 2, args 3, row 7 still, at this position, and then another row, oops, 7, position 5, right? And I guess I should just add some like extras just flying around, so let's just add test 0, 0. We also have 1 and test, sure, 9, no, not 9, 8, 8. We also have 1, right? So now if I do test.solveFish for size 2 and number 1, then basically what I should have after this happens is I should have test 0, 0 is possible 1 x yes, require, so this shouldn't have been touched, this shouldn't have been touched, this, okay, so the 2, 5 should have been removed, the 4, 2 shouldn't have been touched, the 4, 5 shouldn't have been touched, the 5, 2 should be removed, the 6, 2 shouldn't have been touched, same for the 6, 5, and the 7, okay, so let's just do that. So this is this should have been removed, this is this, that should stay, this should stay, 5, 2, 6, 2, 6, 5, 7, 5. Wait a second, that's too many rows. How did that happen? Did I skip or something? So not the 2, 5, the 4, 2, 4, 5 survive. 6, 2 should be removed. No, wait, 5, 2 should be removed. Yes, I skipped over 1 line. So not this. Okay. 6, 2, 6, 5, 7, 5. Okay, so the 7, 5 should be also gone. Okay. Interesting. I guess it's time for debugging because this is weird. Okay. So step into, no, not step over, damn it. Actually, I can just start from here, that's fine. Stop and rerun, yes. So let's see. So let's see at the result. Wait, what? It found 0 and 8. Oh, I guess. Shoot, that's annoying. Yeah, so the problem we are running into is this is a situation that our solver would not run into because or would it run into this? I mean, okay, so if there is only one possible position for a thing, yeah, so this is why I said creating this test is hard, because there's kind of a progression of how we apply our solvers. So this situation would never happen in reality because like you wouldn't have a row with only one thing available, right? Which is exactly what's screwing it up here. I can just add like extra stuff to here. That doesn't really break anything, so sure, let's do that. So let's do this and this. Right. Actually, I should do it the other way around. I'm just realizing. Yes. Okay. Well, let's do it in the inverse way. So we start with a Sudoku that has all the possibilities. And then I basically create an X-wing by just removing some of the possibilities, right? Okay. So let's bring it back. That would be, I think, more sane way to do it and more correct way. So let's just start with this, right? So let's do bloop. So we say the ones are possible everywhere, right? And then we want to create an X-wing, which means let's just remove this stuff and this stuff. So now we have an X-wing here, which should remove the columns 3 and 7. Okay, I think that's more sane way to do it, yes. So for unsigned, let's just loop over this. So so we wanted to keep column 3 and column 7. So we skip over those. Otherwise we remove test rows. We set we want to do row 2 and row 6. I minus equals 1, and the same here. So remove 1 as a possibility. Then swordfish, and then basically what we want is okay. J. So if I equals 2 and J is not 2 or 6, then we require test ij, and just because this will break my brain, I will just change this to j. Right. So require test ij is possible 1. So everywhere in these two rows that aren't these two columns, 1 shouldn't be possible. What the heck happened here? And this should be end. So this shouldn't be possible. And otherwise, no otherwise. If you are in one of those, then okay, I can actually rewrite this slightly. So if we are in this row or in the other row, so I equals 5, yes. So if we are in one of these rows, I can just rewrite this and use the condition. So test ij is possible 1 equals, and this will be j equals 2 or j equals 6. Okay, so basically I expect it to be true when the other part is true and false when the other part is false. Right. And then for the rest of the rows, I want the exact opposite. So else what the heck did I just do? Okay. Yeah, so for the rest of the rows, I want the exact opposite. I want it to not be present if it's part of the fish. Okay. So this should actually work. Okay, and it passed. Okay. So, okay, let's then try to replicate a finned fish. Right. So a finned fish would be if we just add 1 to here. that would still remove this one in particular. But it shouldn't actually touch anything else. Right. So basically I want to do the same pruning as before, except then I come back and on row 5 at 0 I add the 1 as possibility. Then I solve finned fish for size 2 number 1, and really okay, this now gets very complicated. Actually, it will remove the ones from here because the 3 is not really in our thing. This is just the UI showing the number, but ignore that. Like, these two should be removed, right? So this else will be different because this will be else if I equals 3 or I equals 4 and j equals 2, I guess. Else for so everywhere it should be possible except for basically this. Okay, let's see. Okay, let's go through the code. So if you are on rows 2 or 5, then this is fine. If you are not on rows 2 or 5, okay, so this, no wait, if you are not on rows 2 or 5, everything should be possible. Okay, this is curious. But if you are on row 4 and 5 in column 3, then this is basically these two things. It shouldn't be possible. Okay, this is interesting. For this one, I actually really want to see what the heck is the state of the puzzle. What? Not here. What am I writing? No. What? Oh, my brain is shutting down after writing so crazy algorithms. What the heck am I doing? Oh, I don't have... I don't have a city yet. For some reason. I mean, upstream. Okay. Right. So, wait, why is this not printing out? This is showing me the parsed output. I just want the raw output. Okay, this is annoying. I'm not quite sure. How the heck do I see the out? Like, how do I make output out of a test in this framework? Curious. I guess let's look it up. Specific output, sending output to a file. No. Curious. Yeah, this would send the output of the testing framework into a file, but that's not what I want. I'm interested into seeing what my test is actually outputting. But no, wait, there was logging info. Well, okay, this will be a little bit awkward, but I guess I can do it. So I want string stream as debug print into the string stream, and then info as dot string. That should work. Right. Oh, really? It stops? Maybe that's the problem. Let's do it like this then. Okay. Okay. Okay, so this row looks correct. This row also looks correct, except I forgot about this case. Right, is that it? Is that I just forgot about my fin? and GA was not 0. Wait, so this is, oh, this actually has to go here. This is getting complicated. Okay. Okay, I guess now it should pass. No? Still not happy? So what is wrong? Like, this does look correct. Am I just testing the indexes wrong? You know what? I think it will be much easier to do is just test 2 equals test. Do I actually have assignment operators? I don't even know. Yeah, I just deleted all of those. Oh yes, because I have the pointer push it. Yeah. Okay, so that will not be that easy. Okay, let's do it like this. Let's just prepare them the same way. Expect 5-0. And then what we expect to happen is expect at, what was it again? Yes, 3 and 4. So 3, 2, and expect 3, 6. No, what? 4, 6, yes. Oh. Okay, because these represent, where the heck is it? This, yes, so these two need to disappear, yes. Don't maybe need this, but let's keep it around for a bit. And then what I just do require test ij equals expect ij, and I'm done. I don't have to do this crazy logic here. Okay, let's see. Sudoku square. Okay, we don't do Sudoku square comparisons, I guess. Which there's no reason not to. So I guess let's do that. Where to put it? There's a bunch of operators here, so let's just put it at the end of the operators here. Okay. So bool operator equals square on the right side, and this is a const method, and they are the same if data equals our data. true if I have both squares contain the same possibilities. False otherwise, right? Okay. Now it should work. Oops. Okay, so there is still some sort of nonsense going on. Let's just try to print both of them and let's compare, because I really don't know what I'm doing wrong at this point. So 1, 2, 3, 4, 5, 6, 7, 8, 9. What? 1, 2, 3, 4, 5, 6, 7, 8, 9. Why is there so many rows? Am I printing it like 3 times somehow? Or is S-Clear not doing what I think it's doing as oh, it sets the error state. No, that's not what I want. Like this, I guess. Ah, yeah, okay, much better. So where's the difference? The first column is fine. The second column... Wait a second, these two should be... These two in the expect should be clear. How did that happen? Expect 3, 2, so 0, 1, 2, 3. Oh, 2. Wait, what? Okay, there's definitely some weird indexing going on. It cleared these 3 for some reason. No, these 2. Should have cleared these 2. So there's definitely a bug in this. So J does number positions return? No, this should be correctly 0 indexed. But yeah, I mean, this did the correct thing, but in the wrong column somehow. No, so this is the row, K is wrong. So number of shared blocks. Yeah, this is all zero indexed. Where is this going wrong? That's and also, how the heck did this not break any puzzles? This is very interesting. I'm not quite sure where's the problem. I guess we can just debug and see. Okay, so let's see what our indexes are, right? So what is J? J is 1. What? How is J 1? That's wrong. Okay, there's definitely something broken here. Okay, I will try to extract this as a function and see if that's returning something wrong. So, and actually I can reuse it for the actual block checker thing as well, right? Okay. maybe not here actually. I need to put it into a separate thing. Okay. Wow. This code is getting crazy. Yeah, so I basically want like a get fin thing. What I want to give it is a vector of block checkers. So it will be unsigned get fin. It will get a vector of block checkers. And it will get look at the set. This remains the same. Suspecting a bug in this logic, but it's really hard to see. Okay, so let's go for it again. We basically concatenate all the possible positions of a number across the blocks that are part of the result. This is what this does. Then over all the possible positions, I just go over them and I try to find a column could make this simpler and just do it in one pass. Like, since I'm kind of doing it in two passes, this is getting really complicated. What I could do, yeah, not do it like this, but basically do so remember for each column how many occurrences, basically the frequency of the number, right? So what then I can do go over the result for each of the blocks in the result, I get the number positions, then loop over those, but I also want to figure out which column it actually is. Not quite sure how to do this in a simple way. Because I need to remember which column is the one which had the only instance of the number. Hey man, welcome to the stream. I guess if I make it pair instead, yes. So now what I can do is for all the positions of the number, I can do frequency at the position first plus and then equals I. Okay. So this way I remember who contributed. And for those that are more than one, this will keep getting overwritten, but that's fine because I don't care. I only care about the one that's alone, basically. Okay, so at this point, I can basically extract the row out of this. So yeah, so this okay, so this will be the thing. So can I make this function. It would have to be a method, but that's okay. Okay, let's do that. Should be a private method for sure. Okay. Why did you so files? Wait, what? It put it into the test? What the heck? Okay, sometimes this ID is just super weird. Anyway, yes, it's a const, that's fine. So I guess I can just move this here. Technically, I can do this, then I don't have to actually call number position. Yeah, okay, so this will be the set. And yes, I do need to know the number for sure. Number. And here I can just loop over the results. So for if I dot second dot first equal 1, return I dot second dot second. Otherwise I just return maxint. Okay. So okay, so this will actually be the column. Actually, do I want the column and or do I want the row? I'm not sure. What's actually the code beneath the ink? It explains the column. Oh yeah, because then I go over all the elements in the column. Okay. So okay, let's do it this way then. So this will be get call blocks, this will be B, and the number will be number. Okay. So this will get me the potential fin. Something's wrong. No? Oh, because I changed the interface of this method. Yes. Number, yes. Okay, so this is the column that has the fin. Now I need to, where is this fin? and think it's here. Okay, that should simplify things a little bit. So now since I have the column with the fin, the positions, I go over the positions. Oh. Yeah, I also want to know the row. This is tricky. Because here yeah, so I will store both of these and yeah, just to max numeric limits. Okay, and I change the interface again, of course. So this is complaining again, right? Okay. Okay. Okay, so now the P is the that second. So this is always kind of the other dimension. So I skip over the actual fin, and then if number of the shared blocks between fin.second and fin.first yeah, because we are going over columns, so the first one is column, the second one is row, and then J, which is my new row, and fin.second, no, fin.first remains, right, is bigger than 1. Then I keep writing find instead of fin. Okay, so but is this actually correct? So okay, so if I find a J, so if I find the position of this number in this column, which is J, that shares more than one block with the fin, then it is a proper fin. In that case, out of the J position, I want to remove things that also share, like other things that also share a block with this thing. Yes, but this should be rows now. So this should be second. So now it should be that J oh geez. Now we are back to columns because we were column. Now in the column we found the position. So no, that's oh, I need to draw it again. This is getting complicated. Let's think about the inverse one because that one is easier. So this would be the row. We figured out that this is an actual thing, and now this is the thing that overlaps with it. So now we want to loop over the other dimension. Yeah, this piece of code is wrong. Yes, because this should be rows. And I'm checking if my fin, which is fin.second, fin.first, shares a block with this is now also okay. Because those are the positions in the column, yes. Okay. So fin.second number share blocks with so in this case the row no, this was correct. So these are positions in the column, so these are rows. Yes, so J is row. That's good. And then I want to iterate in the other. No, so it was correct. I just confused myself somehow. So this would be definitely JK. That was correct. Okay. So this code now gets a bit easier because this just becomes a row. And this thing I can just copy paste and swap the things around. So get robots, fin dot first, j doesn't equal fin dot second. These things are inversed because now what the heck? Now we are iterating in the other direction. Then the same for this. Okay, same for this. And this should be rect. Okay. Okay. Slightly, very slightly simplified. Let's see what happens to the test then. Oh, the test now passes. So I guess we really did have some bug in this. Okay, in that case, I actually want to see this. What happens with our overall benchmark test? Because technically we're doing the find things wrong, and I guess now we will be doing them correct. So let's see if that helped. Shoot. Well, maybe not. Oh man. Well, fix one things make other things broken. The usual software engineering. Okay, interesting. So actually, we do have a situation where we cannot find a fin. The heck? When did that happen? That's very interesting. So do we actually have a bug in the recursive finder as well? Could be. Okay, so we go over all the positions. Okay. If the total number of positions is one bigger than what we are looking for, then we loop over the positions And for each of them, unsigned set. As we go over the things in our set, check if that has the number at the position. That increases the count. This is super interesting. I have no idea why this would be failing. I guess what we can do is basically, so we have this assert, right? So if fin got first is actually numeric limits, right? Then what we can do is just dump out the current puzzle. So debug print STP. Right. So I really don't know when this would happen. Like if we find a finned fish, quite interesting. Actually, what I can do now is just run it in debug, and then I can see both the output and the state of the solver. Curious. Guess what I should do is create more tests for my solvers. Definitely I'm just testing on one direction, so I should make sure that it works in the other direction as well. Because I could have screwed up some indexes here for sure. Yeah, okay, before I do anything else, let's do that. So let's go back to this. Okay. I can just put this into a separate block. Okay, and I can just copy this entire thing, I guess. And literally what I want to do is just swap it around. Oops. So the things I did to columns, I will be doing to rows and vice versa. And it should work exactly the same as it did before. Right. So let's see. Oh, not this thing. Damn it, this thing. So this is passing. Okay. Oh, actually, let's see. What was the size of the fish where this was failing? Ah, this one. Let's run the wrong thing. Because that will actually tell us a lot more. It's still possible that there's like situations where do I still cannot think. Okay, so size 2, like when the heck would this happen? Okay, so it's for number 4 that it's happening. Wait a second, why am I not seeing the output of the debug print? That's strange. Okay, fine, let's just run it without the thing. I know it's number 4 now. Okay, so where is it seeing? So there's like 2 of them in this too. Okay. So it's like 1 and 1. Okay, so this would be an X-wing, yes. But I mean, there's no fin involved in this. Where is it seeing the fin? Oh wait, it's doing columns, so okay, so yes, there is a fin here. So this, and this, if we do it by columns, this becomes a fin. But then why the heck do we not find it in the find fin? That's weird. It's perfectly valid. Did I screw up the find fin now? Oh man. Okay, I think I will take a break for now. It has been streaming for ages, I think. Yes. I will need to come back to this. Okay. Yes, like I mean, this is definitely a finned fish. And this should be returned as the fin. No idea why not. It's very curious. I think like maybe what I should do is create like a read method that actually reads this format, because then I can basically just copy paste this into my tests and, you know, play with it, and I don't have to like manually painstakingly, you know, try to replicate the code. And I mean, this is actually a perfect example of a finned swordfish because, I mean, X-wing, because he has like these two. So in this block, right, in this 3x3, actually not, because this will not be removed. Wait, there's another one. There's 4 here. So 4, 4 here, 4, 4 here. Wait, but this is like a proper X-wing. What? Okay, this is really like a proper X-wing. Why did this not... I mean, this one should clear the 4 out of here. We have problems. There is something very broken in our solver somehow. Which means that, yes, that means I really need to actually invest into testing for once. What the heck? This is actually a super interesting state of the puzzle. But I really don't understand, like, why wouldn't... Because it is an X-wing, right? Like, so, and it's both on rows and columns, right? Like, there's like... So, sorry, only on columns, because on rows, of course, this one screws it. But, like, if I go on columns, only 2 4s here, and they correspond to these 2 here. Which means I can safely delete this one, because the 4 will be either here or here. So it cannot be here. Well, okay, I guess really I should stop for today, because my brain is just mushy at this point. Yep. Interesting stuff. Anyway, thank you for watching. If you stuck around, if you didn't and you are watching the recording, then thanks for sticking with the recording, because it's super long, as usual. And yeah, have a nice day, have a nice evening, good night, good morning, whatever applies. See you.